In this video, we're going to speak about basic probability. First of all, probability experiments. This is an experiment in which we're talking about how does an individual outcome happen. We do not actually know how an individual outcome will happen, but maybe we know how a long series of repetitions will come out. For example, we don't know what the individual outcome of flipping a coin is, but done over and over and over, we do know that 50% of the time it'll be heads, 50% of the time it'll be tails. And so probability is the proportion of times that an event occurs in the long run. So for example, the probability of getting a head when you're flipping a coin is going to be 1/2, while the probability of getting a tail is also 1/2. Part of that is because you have two possible outcomes, head or tail, and there's only one time that you can get a head out of the two possible outcomes, and there's one way that you can get a tail out of the two possible outcomes. Now here we have the law of large numbers. What this says is the probability experiment is repeated again and again. The probability of times that a given event occurs will approach its probability. So in other words, maybe if we flip a coin 10 times, it doesn't mean we'll get 5 heads and 5 tails, but if we flip a coin 100 times or 1,000 times, we will reach that 50%. So the more times that we do it, the more likely we are to get and approach that actual probability that we expect. Now, sample space, what that means is it contains all the possible outcomes of a probability. Just what I was saying just a moment ago, the sample space of flipping a coin is strictly a head or a tail. So you have two possible outcomes. Here, what we want to do is we want to describe the sample space for an experiment involving a 12-sided die. Well, on a normal-sided die, you have 6 sides, 1 through 6. On a 12-sided die, you have the possibilities of a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and a 12. So this right here becomes your sample space, all of your different possibilities. And so that's all the sample space is looking at, is what are all of your possible outcomes that you can have. Now, an event is just an outcome or a collection of outcomes from a sample space. So a lot of times what we do is we look at what is the probability of an event happening? What's the probability of getting that head? What's the probability of getting that 1 or the 2 on a die or something? Probability model consists of a sample space along with a probability for each event. So there's some notation that we need to look here. Usually we represent A as being the event in general. As you saw a moment ago, I used the head as being that is my event that I want to get. P represents our probability that we are looking for. Okay? And then if I say P of A, that means the probability of event A. So if I want to get a head, I will say the probability of a head. So that means the probability of tossing the coin and it landing on a head. If I want to roll a die and we're looking at the probability of an odd number, I would write it like this. So in other words, we do P representing the probability, and we put whatever we're looking for on the inside of our parentheses. Now we have to talk about what we consider equally likely events, such as tossing a coin or tossing a die. This means that events are equally likely. They have the same possible outcomes. It doesn't matter how you roll the die, or as long as it's a fair die, a fair coin. The head and the tail on a coin, it's always going to have the equal chance of coming up. And so it's not going to be that there's a higher probability for the tail to come up with it being a loaded coin or something along those lines. Same thing with tossing a die. Each side has that equal chance of coming up. And so when we're computing the probabilities with equally likely events or equally likely outcomes, if the sample space has n equally likely outcomes of an event A has k outcomes, then we say that the probability of A, our event, is equal to the number of outcomes in A over the number of outcomes in the sample space. So in other words, how many items are in our sample space would go on our denominator, and how many times that event can come up would go on our numerator. So that's going to be our K, the K events in event A, divided by our N, our total number of outcomes. So think about rolling a die or flipping a coin. If we're looking at rolling a die and we want to roll a 1, well, on a regular 6-sided die, there are 6 total outcomes. And there is only one way that a 1 can come up. That's if you come up with a 1. Okay? So this is the probability outcome that we're looking for. So let's look at that rolling a die. If a die is rolled 1 time, find the probability of getting an odd number. Well, recall that our sample space for a normal die is 1, 2, 3, 4, 5, and 6. So this is our sample space. So that means that our N is equal to 6. Now, odd numbers, we have 1, 3, and 5. So that means that our K is equal to 3. So the probability of an odd number is equal to 3 over 6, which we simplify into 1/2. Make sure that you always simplify your probabilities either into simplified fractions or into decimal form. That is going to be a major key for us in this process. So let's look at another example, looking at the deck of cards. Definitely make sure you know the deck of cards. So in this case, if one card is drawn from a deck of cards, find the probability of getting a 3 or an 8. So we want to look at getting a 3 or an 8. So here's a standard deck of cards, excluding the jokers. And so if we go through here and count, we have a total of 52 cards because there are 4 rows of 13. Now each suit has 13 possibilities because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Each suit has an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. There are 4 different suits: the clubs, diamonds, hearts, and spades. When we're talking about the deck of cards, the ones here are considered your face cards because they actually have a face on them, okay? And so you have to be a little bit careful when you're looking at the deck of cards. But here we want to look at a 3 or an 8. So we're wanting to know the 3s or the 8s. So basically we have 1, 2, 3, 4, 5, 6, 7, 8 possibilities. So our K is equal to 8. So whenever we do this, we have the probability of a 3 or an 8. That's equal to 8 out of 52. We simplify that down into 2 over 13, or if you do it into decimal form, that's approximately 0.154. Okay? Now, discussing probabilities. Probability must always be between 0 and 1. So that means that it can be equal to 0, or it can be equal to 1, but it has to be between 0 and 1. It cannot be negative, and it cannot be larger than 1. So you have to make sure that when you're calculating probabilities, it's between this 0 and 1 item. Now, for the probability of A to be 0, that means that an event cannot occur, okay? It is not possible. So think about rolling a die, a normal 6-sided die. And I want the probability of rolling a 10. Well, if you're talking about a normal 6-sided die, there's not a 10 on there. So that's a 0, okay? Now, we also look at those that have the probability of a 1. For something to have the probability of a 1 means that it's certain to occur. So these cannot occur. Something that has a probability of 1 is certain to occur. Means doesn't matter how you look at it, it's going to occur. That would mean that its probability, we'll say event B, is going to be 1. So again, looking at a normal 6-sided die, I want the probability that I roll something less than a 10. Well, thinking about my sample space on a 6-sided die, it's 1 through 6, it's always going to be less than 10. So that's going to be a 1. So you always have these things right here, okay? When we want to find the sample space sometimes, we may need to use what we call a tree diagram. And the best way to look at a tree diagram is when we look at the gender of 3 children in a family, okay? And so what we do for tree diagrams is we always look at the first possibility or the first occurrence, the first event happening. And in this case, our first event is our first child. So the first child can be either a boy or a girl. We continue the tree diagram with the second event of the second child. Now, just because the first child was a boy, it does not change my probability of being a boy or a girl here. So I still can have a boy or a girl on my second child. Same way with here. whether I had a girl on the first child. Then have the third child, and nothing changes. I still have all of these possibilities. So to get a sample space when we're looking at 3 children, we first start out with all the possibilities of having a boy first, and we follow our tree out. We have a boy, boy, and then a boy. That's how we get boy, boy, boy. Then I can have a boy, or I can have a boy, boy, and a girl. And I get this possibility. Or I've exhausted the possibility of getting a boy second. So let's go to boy, girl, and then I can have a boy, boy, girl, girl. And so now notice I've exhausted the possibilities of getting a girl on my second child. So actually I've exhausted all of my possibilities of getting a boy first. And I have 4 possible outcomes so far. We do the exact same thing following the girl as the first child. I can have a girl, boy, boy. Or I can have a girl, boy, and then a girl. Or I can have a girl, girl, and a boy. Or I can have a girl, girl, and a girl. And so actually, I have 8 possible outcomes whenever we're talking about this event of 3 children. One way to find out if you have gotten all of your outcomes is look at how many outcomes there were for each event. Well, for the first child, there were 2 outcomes. For the second child, there were also 2 possible outcomes, a boy or a girl. For the third child, there was still a boy or a girl, so 2 possible outcomes. 2 times 2 times 2 gives you 8. That's how many possible outcomes there are. That's how many should be in your sample space. And so that's just a way to check yourself. Do I have all of the possibilities? A tree diagram is a great way to make sure that you have all the possibilities in your sample space. So practice some problems with using general probability and sample space, and let me know if you have any questions.